Alrighty. Happy Tuesday, everybody. There we go. All right. We've got a couple things on tap today. We're getting into Chapter 2, finally getting into the textbook here. So we've got today and Thursday to talk about object-oriented programming, all of Chapter 2. And then we'll have a quiz on Chapter 2. I'll probably open that up on Thursday after we finish talking about the chapter. And then we will have our first project, all about object-oriented programming and inheritance. I think I mentioned we were going to take a deep dive on that last semester. Okay. I think chat's working, but this is not. I'm trying to get everything up on the other screen. There we go. And then we'll move on to recursion and get into some array-based sequences. Again, this one's a little bit silly to have to redo it in Python, but we look at how it works behind the scenes, kind of build our own list. It makes a whole lot more sense to do this sort of thing in C++, although they still have a vector. But it's kind of fun. And then stacks, queues, and decks, or DQs, I guess it's pronounced decks. So we'll have a project on recursion, project on stacks and queues and decks. We'll pick up linked lists. We'll have our midterm week. Again, I'm just going to give you all week quiz style questions and some long answer programming questions. No lab. No lectures that whole week, so you've got the time. I want you to actually have a spring recess where you have nothing to do for this class. Sorry, I think my sugar's high. Yeah, that's the high alert. Don't need, it's not telling me to do anything. That's awesome. Let's try like a little bit. Being a cyborg is hard sometimes, but better than the alternative. All right, and then the second half, I will pick up our last project, the individual project, and then we don't go quite as deep into some of these. Again, we will spend more time on trees, I think prior to queues in 350, the data structures and algorithms analysis course. We'll build our own maps. The search trees we'll look at briefly, like a basic simple implementation, not the really good ones that the smart people wrote, but just trying to understand how they might work here. Spend a little bit of time on sorting and selection. Again, looking at the easy ones. You can worry about the hard ones later. We'll do the easy ones. Got some time talking about ethics. That's just like a supplemental presentation. A good chance to chat about how to not be like some terrible companies that have made the news. I guess Uber is not all that recently in the news for their terrible practices, but we still like to poke fun at them. So it sounds like a terrible place to work too. And then final project work time, the very last week. No plans for lecture, anything, just reserved for you folks to work on the final project. Again, it should be in pairs, given we're still in the midst of a global pandemic. I get if you don't want to work with somebody else, but we've got remote tools. You don't have to get near anybody. So ideally, at least pairs, and we can trio up if we need to, if we've got an odd number. My picture's off. There you go. You got to see my whole face in the picture, right? And then presentations instead of a final exam in our slot. So we'll have all of April to work on this final project, which makes up the largest portion of your grade, right, 30% here. And we should feel good going into it, hopefully. Ideally, with all this extra time, we'll have it done, right? And then you can worry about the other final exams and just do the presentations. So should be fun. Again, we're already looking at April, which feels nuts because it's January. But just do remember, it does start getting warmer in April. So we'll get there if you're tired of winter already. But my kids keep hoping for more snow. So, I'm a fan of the snow as long as you don't have to commute in it. I think having to drive in snow is the worst part. Not that it's hard to drive in snow, but like people don't know how to drive in snow, and then it just makes everything worse. You just go slow. It's not too big of a deal.
I don't mind the snow, but it's cold. It gets me.
The cold, yeah. Well, you can always wear more layers. Like summer when it's 80, 90 degrees, there's only so much you can do, aside from going inside and turning on the air conditioning. But
that's a good mindset until you get someone like me who's opposed to wearing more layers.
I used to have a scarf and an earmuffs and all sorts of good things, and I don't know what happened to them. Apparently, I haven't got my winter gear out yet.
See, this is my winter coat right here. It's also my fall coat, my spring coat. Keeps me about 1 degree warmer.
And 1 degree makes a difference.
Sometimes.
Don't listen to Big Coat. They'll tell you, turns out people who die of hypothermia still were wearing coats. So clearly, doesn't solve the problem for you. All right.
Something else entirely.
All right, we'll get here. Let's see. New project. Do you like naming them by week? Is that going to be easiest to follow up on then? So I just call this 2001, 2022, week 2. All right, instead of by topic, then they're a little easier to find, I think. Why does it want to do? I want 310. Give me the latest. I guess I should just get rid of 37. Excuse me. All right, so again, Python is trusty. Python assumes people will do the right thing and not poke at stuff they shouldn't poke at, which generally is fine. Other languages have a little bit stronger protection around this sort of thing. But when we start talking about object-oriented programming and writing our own classes, this idea that a class will encapsulate all of its details together. Generally, they're nouns. They don't always have to be, but that's generally how we like to work with things because we understand nouns, right? You understand spray bottle, and that there can be more than one kind of spray bottle. They can have different amounts of liquid inside of each one. They might have different nozzle types. Any of the attributes about this object, any of the properties can become attributes of my code, right? And then the methods or the functions that we write are ways that we interact with it. I could have a spray method. I could have a fill method. I could have a drink, although I don't recommend that, unlike our former president, I'm sorry. Still have to poke fun at telling people to drink bleach. It's just boggles my mind. All right. So if we write a class like spray bottle, right, then we get to define all of the attributes. So typically we'll put all of these in the special init method. So under init, given self. And self is that magic attribute that is the current instance we're working with here. So then if I want an attribute to be private, which generally all of our attributes are private, and if you want to give someone access to it, you make a public method. Not always the case, but generally that's good practice so that we can enforce the integrity of our class and make sure they don't do a bad thing like, hey, let's change your volume to a negative number and break the laws of physics. Pretty sure you can't have a negative volume in an actual bottle, I think. I didn't actually take physics, but I'm pretty sure that just works. So we can say, I want a underscore volume, right? And then if you're dealing with anything with units, it's always good practice to put what the unit is. Because just volume, some people might do ounces if they're using the terrible system, or smart people might use milliliters because the metric system is much superior, right? So tell them, okay, so this is volume in milliliters, right? In milliliters. I can never spell this one. Milliliters. Is it 2 L's, 1 L? Yeah. So init, this is our method. It's like the constructor that makes an instance of the spray bottle. So when I go use my spray bottle class, init gets called all the time.
Oh.
Yep. Milliliters, is it 1 L, 2 L's? I forget. We'll just start off at 0. So that's our volume in milliliters. And maybe this should be current volume in milliliters, and maybe we'll also have a max volume in milliliters. And then we need to know what our max is. And I don't know, I don't actually know what it should be, so maybe we want it passed as an argument. So if I want something to be passed to this, so to make a spray bottle you have to tell me what size it is, let's give it a max volume in milliliters argument. Again, this one probably won't have the underscore because it's not a private attribute here. Is it telling me I typoed it? It is. 2 L's, right? Yes, it is 2 L's. I thought it was, but then it looked funny. Okay, so you have max volume in milliliters is whatever you give me as an argument. So if you want to make a spray bottle, you have to tell me the max volume. Great. Probably don't need anything else right now. That should be enough for now. Now, how do we interact with our current volume? We need to give them public methods. So we can give a method like add liquid. Given self and, I don't know, the milliliters to add. Milliliters to add. And I can take my current volume and I can add to it the milliliters to add. Pretty easy, not too bad. I'm sorry, it doesn't know what that is. It's self dot. So self dot current volume is going to be this current instances. So I can have 3 different spray bottles in memory. I can have one for bleach, I can have one for vinegar, and I can have one for water for spraying the cat when she gets up on the table and she's not supposed to. Right? Don't mix those up. That would be bad news. Please don't abuse your cats. Cats are lovely. So this is fine, except I haven't really done any checking on milliliters to add. Right? The whole reason I want to have a method or a public function here is so that I can control what happens. I don't want someone else to be able to put my class in a bad state. Right? So we need to do some protection. We need to check, hey, if the milliliters to add is greater than 0, then let's go do the thing. If you give me something that's not greater than 0, let's forget it. Hey, hola, thanks for joining the chat. Yeah, the underscore before a variable indicates that it's private. That's our convention in Python for private variables. I mean, don't touch this outside of the class. It's not a hard and fast rule. You can do it in Python, but you shouldn't. Like, Python is trusty. We're going to assume people will do the right thing. And tools like PyCharm even go and hide those things for you, which is nice. So if we say here's bleach equals a spray bottle, and then I can say bleach dot, and I get add liquid, I can see the init method, and I don't see any of the private variables. They're not visible here in the IntelliSense, in the type ahead. They're still there. I can still go to current volume in milliliters. Volume in milliliters. But like, it's not even trying to be helpful and give me what I'm supposed to type here. I could set it to something ridiculous if I wanted to. Python will let me do this, but it's real bad form, right? Bad form. Don't do that.
So you make it private from the underscore.
Yep. So it indicates that it's private, and we assume people will do the right thing. But you can do bad stuff if you care. So it just hides it. So that's that idea. We're encapsulating all the details. We're hiding away all of the variables so you don't have access to them and forcing you to use the public methods here. Part of that's that idea of abstraction. You get to work with the abstract public interface. Anything that I give you that is public, you can touch. Anything that's private, you don't get to touch. Right? So you get to use the public methods that we can do some sort of these controls, some sort of these checks to make sure we're doing the right thing here. So after we've added that, I need to make sure you didn't pour more into the container than actually fits. So you might have said, hey, I want to put in 100,000 milliliters. This bottle does not fit 100,000 milliliters. It fits 946 milliliters, of course, because it's 1 quart, because our system's awful. Can't they just make a liter? So we need to check. So we can say, hey, if my self.currentVolume, current self. Not even giving me that type ahead. Come on,
I think it's not giving it to you because you need the self attribute in the init method too.
I've got. Oh yes. Thank you. Yeah, self dot. Thank you. That looks so much nicer. We would have found that soon when it stopped working. Pretty sure. All right. So if my self current volume in milliliters is greater than my self.max volume. Self.max volume in milliliters. Oops, too many underscores. If I overfilled it, right, let's set my self.current volume to the max. And we'll just pretend whatever else you tried to put in here just spilled all over the floor or something. Again, a lot of people, when you're learning how to program, your instinct is here, you should put a print command and say a bad thing happened. Print, you spilled. Don't do that. Right? A class's job is almost never, ever to print anything. Right? The class could care less how it's being used. You could use it in a web application. You could use it in a mobile application. You could use it in a graphical user interface application. Maybe you're using it at the console where someone might see a print command. The class has no control over that. So don't put print commands in classes. Right? If you want to print something, do it in the part of the program that you know is a console-based application. The idea with building classes and building objects and this approach to object-oriented programming is reusability. I want this amazing code that I wrote to be useful other places. So if I put print commands here, it's not useful in other places. Now, it's not always the case with Python. We're going to be using this in web applications and all sorts of fancy things like that, but maybe we could. Right? Probably we're not going to make it a no mobile app, but again, we want to build with that sort of reusability in mind. So what we can do this sort of thing. What we could do is we could return a value. We could return a true or false if we cared to let them know, hey, yes, you were successful, or false, hey, something bad happened. That's an option, right? So if this all worked here, then, and we overfilled, we could return false. A bad thing happened, right? If we filled and we didn't overfill, we can return true. This filled okay. This is overfilled. And then if we didn't add anything here, right, then we can return false. Right, you can't add negative. So one of two things is going to happen. Either you're going to get back a true that it worked or a false that it didn't work. Right? Again, it's not super descriptive here. You kind of have to figure out what you did wrong on your own. This is one approach. I think exceptions is better, but we'll take a deeper dive into exceptions later. And we can figure out how we can use exceptions again in a couple more chapters. So again, just giving it true false is probably enough indication of this. Not too big of a deal. So then in my spray bottle, when I'm using it, I can say bleach dot add liquid, and I can go add a bunch here. But in my spray bottle, I need to tell it what is the max. Probably we'll do 1,000. We'll do a liter here. If I try and add too much, then I can check the result. I can say my result is something, and if my result, then print, I don't know, it worked. You filled the bottle. You added bleach. Good job. Or else, I don't know, print, it didn't work. So maybe we should ask them, right? Instead of just adding some liquid here, we can try it. Well, let's say, hey, here's the amount to add. Add is an int of an input of, what should we add? In mLs. Is it lowercase mLs, uppercase mLs?
I think it's lowercase m, uppercase L.
mLs? That looks weird. MLS? I don't know. Sure. Or we could just type out the word milliliters. It's not too bad either. There we go. And then we'll add that amount. And maybe it worked, maybe it didn't work. It didn't work. Sure. And we can run it. So we can use our class here, so we can add some liquid to our spray bottle. Come on, right click run. There we go. So how much should we add? 20. You added bleach. Good job. Let's run it again. How much we add this time? Minus 20. It didn't work. Again, we sort of don't really know why it didn't work, but that's okay. We could do better checking here later, that sort of thing. But the point is the class doesn't let you do bad things here. And if we try and add too much, it didn't work either. Right? So we're making sure the class is making sure that it doesn't get put in a bad state. Objects should protect themselves from not even malicious input, but just stupid input. Users will do the weirdest things to you. So we want it's called defensive coding is the proper term for it. We're making sure that basically anything we're ever given, we're checking for bounds, making sure it's valid. We're defending ourselves against being put in a bad state. It's a good practice. Okay. Now, sure, that works, and then maybe we need a way to spray. So we could either have a fixed amount to spray, or we could have a variable amount to spray. You could say, hey, I want to spray 100 milliliters, or I just want to do a normal, I don't know, how much do you think comes out when you just spray it? Like 5 milliliters? 10? We could guess, right? And why don't we take advantage? We can use one of those default arguments here for fun. Right, so we'll have a amount to spray. We'll say, hey, if you don't tell me, we'll assume it's 10. Right, with a default argument here. If you don't give me the value, I'll assume it's 10. These are fantastic. So we'll take our self.current volume in milliliters and subtract the amount to spray. Now again, we want to do some sanity checking. If it went negative, we should do something. And maybe we even want to check that that is a positive number. Same kind of idea here. So if my amount to spray is greater than 0, I'm good to spray. Right? If it's not, then I can return a false. Right? Something bad happened. Sure. Right? If it's a positive number, let's go ahead and try and spray it. And then let's see, did we go below 0? So if my self.current volume is less than 0, we did a bad thing. Well, you sprayed the rest of the bottle, but we now have 0 left. We need to fix that bad state that we're in. Right? You sprayed the entire thing somehow. I mean, I don't know, spray 1,000, went nuts on it, go for it. You sprayed it all, but now we're back down to 0. Right? Can't have negative volume, and then we'll return false. You did a bad thing here. If that worked and we didn't go below 0, we can just return true. Sure, you sprayed. Again, exceptions are probably better, but this is, this is an option here. So this is invalid state. This one is fine. Everything okay. And invalid amount or something. We're not giving back. We could give back messages too, and we've got all sorts of good options. But I think a Boolean's probably pretty simple for now. And again, we'll get back to exceptions later. We'll feel a little bit bad about it, but it'll be okay. Right? So we add some, and then we should spray some. Right? So then we can take our bleach bottle, and we can call spray, and we can spray an amount if we want. Sure. I don't know. Why don't we do this? We'll have a result is my bleach spray, and while result is true, or while result, right? Because if it's true or false, it already is either true or false. I don't need to say if true equals true. A lot of people do that. They'll say, hey, if result equals true, which is redundant because it's already a true or false value. Save yourself some typing, and PyCharm even tells you that you did a silly thing. And we'll keep on spraying. So we'll print, you sprayed some bleach. And then we'll spray again. And resetting result every time. Once it's false, we're all done. Right? And then we can print bottle is empty. Right? So as much as we put in, we should be able to spray. And again, this is like 10 at a time because we didn't give it a value here. So if they had like 100, we'll spray. It looks like about 10 times, right? Let's see. Is that 10? That is 9 lines, 9 line breaks. Right, this little, it tells you down here what you selected. PyCharm's pretty handy like that. I think you can kind of see that. So I think that's a total of 10 lines. Because if we go down one more, then I've got 10 line breaks. Yeah. That looked right. So we sprayed it 10 times. We ran out of bleach. Life is good. I guess that, yeah, the last time wouldn't have worked, right? Because the bottle was empty. We would have got down to 0 even. Okay. So again, just some basic. We're writing the class. We have public methods, so they can interact with their class abstractly. With this idea of abstraction, they get public methods. They don't need to know the details. I mean, this one's not hard to figure out. But we want to start with some basic examples and make things harder and harder and bigger and more complex. But everything you work with is public methods. If you want something passed to you, notice this class also doesn't have any input. A class should probably never have an input statement. So again, we don't know if it's running at the console. If you want something given to you, you ask for it as a parameter to your functions. So okay, you want to add, you tell me how much you're going to add. The part that's calling your code is responsible for getting that input from the user. So the other useful thing for this is we could make a file with a bunch of spray bottles. Right? It doesn't all have to come from user inputs. Right? If we had a bunch of file input data, but my class asked for inputs, our program wouldn't work. So maybe that's probably actually the more common use case. If you've got a file full of data that we're going to go and model, right? We can load it out of the file, call all the methods that we need to, never need to run inputs. Right? But if you just want to test it out, run a little bit, try some examples yourself, sure, we can write one where we're getting some keyboard input. Go for it. Right? Either way, we want to try and play with it and have fun with it works. You okay so far? So what I've done here is manual testing. Right? I've had to go through and make sure that, yes, it does what I expect it to do, and I'm eyeballing it using my eyes and saying, okay, yes, it looks like it does what it's supposed to. And before, when we added a bunch of values, I tried 3 different values. So we had to run it and check, and run it and check, and run it and check. This is not ideal, right? People are bad at this sort of thing. Just like it's hard to proofread your English papers because you know what you meant to write, and you don't see those typos. Same thing goes with our code. Right? It's possible to miss this sort of thing because we're bad at it. So it turns out what's good at it is computers. So we're going to write code to check our code. It's called unit tests. We want to test 1 unit at a time in our code. So PyCharm is really good at this. I think other IDEs probably have some similar things because unit testing is big. But we're going to right-click the class and say, go to test. And it says, oh, we don't have any tests. Do you want to make some new ones? We say, yes, please. It says, okay, I'm going to make a file called test main. Go for it. It's going to test the spray bottle class. Great. And then we can even have it generate some test code for the functions. Any public functions, I'll say, hey, do you want to test these? We'll say, yeah, go for it. Now I have 2 files in my project. and it automatically writes a little bit of test code for me. So I'm saying from unit test, import test case. So we're going to inherit from the test case class that's built into the unit test library. Okay, this is already out of the box, ready to go here. And the idea with our tests is we want to, instead of us typing something in and looking at the results, saying it gave me what I expected, I'm going to make the code do it. So we use this AAA convention. So first we're going to arrange our variables, and then we're going to act, which is calling the code. We are testing. So arranging is setting up the variables we need to test with. Act, and then we're going to assert, which is, did we get what we expected? So it's just a convention. It's not a hard and fast rule, but this is a relatively common convention in the industry. And if everyone writes tests this way, they're really easy to read. Because if you follow the convention, people just know what to expect. Right? They can go look at your tests if they have any questions. Works out pretty well. So for adding liquid, right, we're going to have the ml milliliters to add, let's say, is 100. So if you want to add 100 milliliters, great. And then what we're going to have is, actually, what we'll say, yeah, that's fine. We can do another variable, and then expected current volume. I don't know, we don't even have that. So then we want a result, right? So our expected result is going to be true. We should be able to add it. These are the two variables I need. Now, the other thing I need here, I'm not actually testing the init method here, because it just sets those two things. What we want to test is add liquid. So I'm going to call that init here. So I'm going to have a bottle equals a spray bottle. Spray bottle. Nope, spray bottle. Given, I don't know, we'll say size 100. And it says, oh, I don't know what a spray bottle is. We need to add our own imports. Right? So add from main, import spray bottle. Right? Main is another Python file. You can say import one class at a time, or you can just import the entire file or the entire module, and then it's file name.class name. So this is a little bit nicer. Import, right, from the main module, import the spray bottle class. And let's give it the milliliters to add, I guess, because we want that to work. Okay, so we say how many milliliters I'm going to add. We have our expected result, and we make a spray bottle. We call that init method. Now the actual code we're testing is adding liquid, and now really this one is the successful. Successful. So we want this one to work. We expect this to work. So my code that I'm testing, my act section, I'm going to have a actual result will be my bottle.add liquid, and we're going to add the milliliters to add. So if I try and add 100 milliliters to a bottle size 100, I should get back a true. So in my assert section now, did we get what we expected? Self.assert equal, and we can say my expected result and my actual result. Do they match? Are they equal? Now there are, like, you can just assert something is true or assert something is false, but I think this is going to be an easier convention for us to follow. So what did I expect to get when I actually called this code? Right? So we're saying, if I do that just like we did when we ran our program, I said, okay, let me add 100. Did it work? Yeah, it worked. Great. So let's see if it works. So now we're going to come up here and we can run our test. Run tests. And now you get a cool test result section here. Oops. We have this other code here. So it's sitting here waiting. I did a bad thing. So we need to hide this other code here. We can say if, what is it, under name equals, is it under main? That sounds right. Not that one. So there's a special name thing. If you run a Python file, the file that you run is named main. A funky thing. So if you have code in a class, this is bad form here. I shouldn't have this code in my class file. But this is where we started. So this kind of hides the code so that it will only run. Code only runs when you directly run this file. So if I say, hey, I want to run the main.py file, name will be main, this stuff will happen. If my test class goes and runs this file, because when you call import, Python actually goes and essentially grabs that file and just jams it in. Says, okay, you want to import? I'll take all of that, drop it in right here. you're good to go. Essentially, puts it at the top. It's a little bit more nuanced than that, but that's pretty much what happens. So when we tried to test, it was saying, oh, hey, you wanted to go do something. Here, you waited for input. Another reason it's bad to have inputs in class files. Right? You can't test them. Let's try this one more time. Let's rerun our test. And now my test passes. I get a nice green check mark. So it's cool. It was successful. So what I want to do, I feel pretty good that part of my code works. I know that I was able to add and that I returned true. This block of code has never run, and this block here didn't run. So there's a way of describing tests, or unit tests called code coverage. It is how much code actually is being exercised or ran while the tests are running. It doesn't actually mean that you're testing for it, but it means at least that line of code ran. So a lot of organizations have certain goals or targets around code coverage, and they'll say, hey, maybe 80% is a good goal or 90% is a good goal. If you can get to 100%, that's phenomenal. It's not always worth it because it takes a lot of time, energy, and effort to get to 100% code coverage. I'll say it's a good goal to have, but not like a hard and fast rule. So a lot of that's a business trade-off as well. Like how much time do you want to spend into making sure that it does everything, especially when you have a lot of defensive coding like this. Like it's a lot of tests you have to do just to make sure that the wrong input is ignored. It's still important. And I would say any code that's worth writing is worth testing, right? Because otherwise, if you don't care if it works right, why are you paying me to write the code? Right? You probably want code that does what it's supposed to do, and that's what my tests are checking. So again, it's a little bit of a business trade-off, but generally whoever writes your paycheck, just kind of smile and nod and go with that, right? As long as you're doing some testing. All right, so this was our test for successful. So we want to test, again, so I'm going to copy paste that whole method, or the whole function here, and we'll say this is, we'll say fails on negative. So if I try and add a negative 100, and let me just fix this to just be like 100, right? My expected result should be false. If I try and add a negative number, I should get back a false result, right? So when I assert my expected result false should match the actual result false. So we're going to test that section of code there to make sure it fails if it's negative. And this is fails on overfill, maybe. Overfill. So if we were to add 100, and our bottle had, I don't know, that divided by 2 only fit 50. Again, you could just put other numbers in here too. It doesn't have to be based off the other variables, but I like when things are based off the variables because it makes copy pasting easier. If I try and add 100 milliliters to a 50 milliliter bottle, I should get back a false. Right, so I can just go and run all my tests. I can just hit run over here in my test explorer. Should run all of them. Oh, I'm sorry, I just ran the one. So let me go up to the class and rerun. So at the class level, it'll run all the tests. And add liquid fails, passes. Add liquid fails on overfill, passes. Add liquid successful, passes. Test spray fails because, hey, it says fail. All it does is fail. We expected that one to fail. We'll go fix it in a second. But now I feel better and more confident that my code did the right thing. Again, it's still possible to make mistakes. I still could have done the wrong thing in the class code and tested that the wrong thing happened because I just misunderstood what was supposed to happen. I just had like a logical error that I didn't really understand what my code was supposed to do, and I told it to do the wrong thing. So it's successfully doing the wrong thing. Still possible, right? We can still make mistakes, but we're much more likely to be successful here and be correct because we're testing that it does the correct thing. And hopefully we've got a good understanding of what it is. So it helps reduce the amount of bugs we're going to have, the amount of errors we're going to have in our code because we've done this unit testing. And I have 100% code coverage because I know every line of code in this method gets run at least once while I'm running my tests, right? I get to this return false, I get to this return false. So basically every time you have an if or an else block, you want to test to make sure you get inside of that block to make sure that code runs. And there's tools you can get. Generally, you have to pay for them that will measure that sort of code coverage for you, so you don't have to eyeball it. That's better. But again, we're not going to pay for anything, so we'll just go for it. I think the premium version of PyCharm does it for you. I want to say, I think it has that if we were to get the professional version, but we just use the free one, so that's fine. Yeah.
Is SOR equal both and function?
So it's part of the test case class that we've inherited from. So that's why it's a self dot. So it's a function that exists in the test case class. where it goes and checks that. Yep. All right, so we'll do the same thing with spray, right? Spray should be successful one time, and it should fail 2 other times, right? Either we try and spray too much, or we spray negative, it fails, and it's successful if we do regular. So we'll do 3 tests, right? We'll arrange, we'll act, and we'll assert. So I have a default milliliters to spray, so I don't even know if I need to use that value. We could if we wanted to. Oh, sure, why not? So we'll have milliliters to spray, I don't know, equal 10. So we'll call this one successful, right? Successful. Now this one gets a little bit funny here. We want to test 1 unit of code at a time, but we can't test spray until we can add liquid, right? When we start a bottle, our class says, oh, you're empty, right? You have no volume. And then spray would always fail. So add liquid has to work first, but we're not testing it, so we're just going to put that in our arrange section. So we'll make a bottle, equals a spray bottle. We'll say it has, I don't know, size 10, why not? And then we'll call bottle.addLiquid, and we'll add 10 to it. Right, so this is all arranged. This is all stuff that has to happen before we actually care about what does actually work and what we're actually testing here. Then I'll have my expected result, right? My expected result should be true. This should work. My result will be bottle.spray, and we'll say, hey, let's spray the milliliters to spray. And then we'll assert equal that the expected value is the actual result. This should be actual result. Again, it's just a naming convention here, though you always see expected and actual. They don't have to be named that, but it's a nice convention. You can see, okay, this is what I expect to get out, and I assert the same things. It just kind of works nice. Okay, so it should spray successfully, and then we should have some unsuccessful sprays, right? Spray fails on negative. And again, you want a nice, meaningful name here. It's got to start with test. Test is the convention for the test class to find it somehow. It's kind of magic. But then anything else should say what you're testing for. So if something fails, you're like, oh, I know what went wrong here. All right, so on negative, I try and spray a negative value. I should get back a false. And then one more, we're going to test for fails on too large of spray. I don't know. Sure. So if we try and spray 100 and we only have 10, it should also be false. We'll go run our tests. Come up and run, or right-click run. You got lots of options for running, and those ones pass successfully. So we feel pretty good that add liquid and spray are working. Now what we don't have is a way to tell someone what my max volume is or my current volume is. Like if I pick up the bottle and shake it, I can guess, but it'd be nice if the bottle told me like how much it had. So we can add some methods here, like a get current volume in milliliters, given self. We can just return the self.current volume in milliliters, and define get max volume in milliliters. Volume, no, there's no N there, shoot. Can't spell. Volume in milliliters, given self, we'll return self.max volume in milliliters. So if you want to know what the values are, we can give them back to you. Because we've said that they're private. We've encapsulated these details. We need to give you a public way to access them if there's something you need. So a lot of times you'll say there's accessor or mutator methods, set or get methods. I like set and get because they're a lot easier to say than accessor and mutator for accessing and changing or mutating. I think those are funny words, but some people use them. Yeah?
So Professor, you wrote those methods for the user to get see the private.
Yep. So that way they have a way of seeing what the values are. Yep. And these are actually, they're going to be returned as copies, so they can't change it directly anyway, because it's not a reference. We'll talk a little bit more about that later. But I'm giving them a copy, essentially. So they can see what the current volume is, and they can check it out. So testing get methods is kind of silly, but we'll do it just one time, and essentially that helps us test the init method. Most of the time, if you have an attribute, you're going to give someone a get method so they can go see it. Right? There are some cases where it's completely a private attribute that no one ever needs to know about it, sure. but for attributes like that help describe an object, like the current volume or the size or the color or the, I don't know, spray lever handle length, nozzle position, any sorts of things you can come up with, you're probably going to have public methods so they can get those values back out. So we don't need to write a test for every single one of them. I'm going to write one that creates a spray bottle and tests both at once. I'm not going to feel too bad about it. So generally, we'll just lump all the gets together at once here. So we'll add one more test here then. And I'm just going to say this define test gets. So we'll arrange, we'll act, and we'll assert. So I'm going to have a expected current volume in milliliters. Liters is, I don't know, let's say 50, and an expected max volume in milliliters, we'll say is 100, and then I'll make a bottle. Bottle equals a spray bottle, given the max, my expected max volume, and then I'm going to add to it. Right? If I just take the default and I never add, yeah, I guess I'm testing it, but like anything defaults to 0, you got to be careful with. So testing a number that's not 0 is good. So I'll say bottle.add liquid. I'll add my expected current volume. I'll add to it, and then we will act. I'll have an actual current volume in milliliters. Milliliters is my bottle dot get current volume in milliliters. Did I spell that one wrong? I did. There's another T I'm missing. There it is.
You're missing the L.
The L? Oh, that's a T. Okay. Milliliters, not liters. Milliliters. Spelling is hard, friends. Spelling is hard. I haven't been doing English forever. Actual max volume in milliliters. Liters. My bottle.get max volume in milliliters. And then I can assert they match. You can have more than one assert in here as well. Assert equals my expected current volume and my actual current volume. And I'll assert equal, assert equal my expected max is the actual max. So it seems like a lot of work. But again, what we're doing is we're making sure that the code we wrote does what we expect it to do, which is really very valuable. Like if you're going to write the code, like when you folks do your projects, you want to make sure that it works, right? You don't want to turn in code that may or may not work, and you don't know if you're going to get a good score or not, right? So you're going to test it. So we're just making the computer test it for us. The next big benefit of having unit tests is this idea of a continuous integration or continuous deployment pipeline. There's all sorts of cool tools that will hook into source control, and anytime code changes in, say, your GitHub repository, it will run all of the tests out there. It's phenomenal. It's a really cool feature. So you know right away if you broke something, or if someone else broke something, right? The asserts all of my tests here kind of encode that this is the behavior I expect to have happen. If it stops doing this, something wrong happened. As you work on larger and larger and larger scale projects, it's easy for small changes to have some sort of cascading effect. So having this sort of test coverage and having automated testing, a continuous integration testing tool, is invaluable, because we're going to find out right away if the behavior changed from what we expected. And that keeps you from giving bad software to your customers. Don't be like Windows and let everyone beta test stuff for you. That's just not cool. I mean, they're better at it now, I guess, but still, like, people are lazy and they ship code that just doesn't work, and then they go fix it. Let's try and avoid that. Beyond that, we can move in this software world to continuous deployment, in that if my code passes all the tests, I can automatically go update wherever it runs in production. So a site like github.com actually runs itself on continuous deployment. So when their developers make changes to the site, it passes the tests, it'll automatically go and update their website. I've got friends I used to work with who work at Khan Academy now. They have the similar process, right? And it's just a good developer workflow. So as a developer, you go do your work, your unit of work, you make your pull request, it gets reviewed, you merge it in, the tests pass, it'll automatically update the production website. No additional work needed, which is fantastic. Ops people love it. It's awesome. That's what DevOps is all about. That's always lots of fun. But if you have code and it can, in this pipeline, just make it out to production automatically, if the tests pass, you're going to feel pretty good that it should do what it's supposed to do. Again, there's all sorts of other cool things you can do to make sure, like feature flags and hiding things, and software is really fun. Really, really fun. You can do all sorts of fun stuff. But if you're not testing it automatically, you've got to go do it manually, and it's failable. So again, ideally we get 100% code coverage, and we trust that we did it right. It's still possible to screw things up because we're human, and we could screw it up twice in a row. Yeah, but you're less likely to screw it up twice in a row. So you're going to feel pretty good if you've got good test coverage. This one okay so far? A lot of recap. If you already had 1501, apologies, but I got a level set for everyone coming into it. All right, cool. Yeah, I'm just going to get out a couple of those. So let me commit this here to the GitHub repo as one commit. Right, commit early and often so you don't lose your code. Just give it a second to think. There we go. 2001 winter. Here's spray bottle. And tests. Awesome. We'll commit and push that. All right, while that's working, let's go back to PyCharm. And let's look at some other classes we can write here. So I want to, let's say we're going to run a store and do some sort of point of sale system. Right? We can have a bunch of items that we're going to sell. We can figure out what tax is. We can print receipts for people, do all sorts of that stuff. Right? So I'm just going to add a new file here just to keep this all separate. So we add a new Python file. We'll call this my, this will be my item class. I'm fond of having one class per file. It's not really the Python way. I apologize. It's just, I like it. It looks nicer in source control, and I think it's pretty. I'm going to find a class for item. Right? And then item has a couple properties. Right? So anything that we're going to sell, init. So we'll define a self dot, how about a name? And you probably have to tell me what the name is. And you probably have to tell me what the price is. And probably the quantity that you have. So self.price is the price, and self.quantity is the quantity. Right, so as something that we're going to sell, some item to sell, name, price, and how many we have. Okay, we can do all those. So then we probably want some get methods, like get name, turn self.name, a define get price, turn self.price, and a define get quantity, given self return self.quantity. Okay, those are pretty straightforward. So we'll make an item, and then we'll go set these values. Now, when it comes to an item at a grocery store, we want to think about what things are changeable and what things aren't changeable. Right, so you're probably not going to change the name of an item. So I probably don't need a way to set the item name. Right, once I put this item on the shelf, it's probably still going to be called macaroni and cheese. But what could change is the price, right? I could charge more for it. I could charge less for it. Put it on sale. I can clearance it out. We got all sorts of options. So price should be changeable. So we should give someone the ability to change the value of price. We're going to define a set price method here, given the price. So I can say my self price equals the price you give me. Again, this is not, self price, self. Not great here, right? We want to actually do some sanity checking here, right? We don't want to give things away for free, right? Price should never be 0 or even less. That's even worse, right? If you're giving people money for buying items, that's a really bad typo to have happen. And it turns out, if you've ever noticed, the people who do like data entry jobs, the store clerks and people who are like punching in, scanning things, they get paid the least, so they could care less, right? They honestly, they're there putting in their time, and they don't care. It's the weirdest thing in hospitals, the people at the admission desk, right? When you're going to go admitted at the hospital or check in, they're the lowest paid people. So if they get your name wrong or they pull up the wrong patient's record because there's 2 of you out there and they get the wrong one with the wrong allergies, they don't care. But if you get a medicine you're allergic to and die, it's because they put you in as the wrong person. right? And they're the lowest paid people at the hospital. It's awful. So mistakes happen from users. So again, let's be a little bit more defensive here. So let's say, hey, if the price is greater than 0, then we'll take it, right? And again, maybe we could return a true, maybe we could return a false. At this point, we're going to skip it because we're running short on time. I don't want to spend too much time on that, but to do defensive checks, sure, you got it. Look at it, even highlights it as a to-do. How pretty is that? I love it. PyCharm is awesome. Same for quantity. I'm sorry, that's a get quantity. So quantity can change, right? I can restock an item. I got more in stock. I'm going to go put more out on the shelf. Apparently, it's really hard to find ramen noodles in the store lately. Try and get them like every time we get an order because my kids love ramen noodles, and we get them like maybe once a week if we're lucky. I can get a couple. It's just hard to find them on the shelves. But sure, we can have a quantity. So maybe we'll have a set quantity. That one is changeable for an item. Quantity given the quantity. So we'll say self.quantity is the quantity. And again, probably we'll do the same thing. If quantity is greater than 0, we'll take it. Probably don't have negative on the shelf. 0 is okay, right? So maybe less than or equal to 0. This probably makes sense here. Where price is probably never 0. Probably never give things away, right? Probably have some floor, but for quantity, 0 is okay. Like I'm out of stock of this item. I still have it. It's still in my system, but I just don't have it in the store. I can't sell it to you, that sort of thing. Okay? I don't know. Sure. And we can do other defensive checks too. Right? Return values. Sure. That's okay. So those are changeable values, right? Or mutable properties. Right? They're ones that are supposed to change. So I don't want to have the same logic twice, right? Anytime you have the same code twice, you should feel bad about yourself. So I don't want to do those same checks here. So I just want to call self.setPrice, given price, right? And self.setQuantity, quantity, given quantity. And if I've got a set method that does that logic for me, let's let my method do it. Okay. Now it does warn me. It's saying, hey, quantity is defined outside of init. Technically bad practice. But we could set it to 0 and then call set price, and that just feels a little silly. It's like these ones are simple enough. I'm not too concerned about. Generally, init should be the only one like creating new self dot values, but they're just basic sets. It's nothing too complex here. The reason is that after you call this init method, when you make the object, all of the properties should be set. If one of these methods doesn't get called and it's setting something, elsewhere in the code, if we're trying to use that value, it might not exist. It might not have been set. So generally, you want to make sure init is setting all of these, but we are setting it through init, so it's probably fine. And just it'll warn you, and we'll be okay. Right. So I've got item, got name, got price, got quantity, that sort of thing. Great. Now we need a way to like buy the item. Right. Buy. And tell me how many we're gonna buy. Quantity to buy. Right. Hey, let's go buy 10 packs of ramen. Right. So first we want to check if the quantity to buy is less than or equal to the self.quantity. We're okay. We can do this. Right? If otherwise, we're going to return false. That didn't work. Right? Or maybe even 0. How about 0? So how about we tell them how much it costs? Right? Otherwise, then we can take my self.quantity and we'll subtract from it the quantity that they want to buy. We know that works, and then I'm going to return the quantity to buy times the self.price. Right? So it costs you 50 cents to buy 1 pack of ramen. Oh, it's like 10 cents, right? 20 cents? 19 cents? Depends if it's on sale or not. So if you want to buy 5, right? 5 times 19, 95 cents. Sounds right. Okay, so we can buy some. Cool. So that's our public method. Again, set quantity. If you just want to set it outright, great. We could go for it if we want it. Otherwise, we could say like have a restock method that adds to it, or I don't know, like buy will subtract. I feel a little silly having set now because you could just change it, but it's probably fine. So sure, you can go buy it. Right, so that's item. Now, I've mentioned tax before, but in Michigan at least, sales tax is only charged on certain kinds of items. Right? So fresh foods are not charged sales tax, but prepared foods are for reasons. Again, I don't really understand all of it. So not every item is taxable here. So sometimes item is fine here. So maybe if we did like bananas or apples, right, that don't have tax. So ramen should be taxed. Now, I don't want to reinvent the wheel. I don't want to do all of this over again, right? So what I want to do is I want to add another class here. We're going to call it a taxable item. And we're going to use inheritance. Inheritance is another fundamental of object-oriented programming that says I'm going to be everything that this class is, and then I'm going to be a special version of it. So we're pretty familiar with inheritance thanks to like biology class, right? When we classify things that kingdom, phylum, class, order, family, genus, species, which I don't know why that's still in my head. I haven't taken biology in 15 years, I want to say. Like, I shouldn't remember that sort of thing, but okay. Right? Everything that is a mammal shares a certain set of properties because we're mammals. But dogs and people don't all have the same set of properties. We all share the mammal properties, but then we're special versions of mammals, right? That sort of thing. So inheritance does that sort of relationship. You are a type of your, what we'll call the parent class or the superclass or the base class. I don't know why there's so many terms for it, but you have parent class and child class, you have base class and derived class, or you have superclass and subclass. Go for it. I think super is probably what we'll use in Python, but you might hear it all sorts of different ways. So for my item here, I'm going to say, hey, I'm a taxable item, and I want to inherit from item. And it doesn't know what item is. We got to go add our import. So we'll say from item, import item. Okay. So inside the parentheses here, we can declare that we want to inherit from another class. This now becomes our superclass, or our parent class, or our base class. We do all of the things that class does right off the bat. We just get to basically absorb all of it. So all of the attributes we have, all of the methods we have, we do all those things. Now we want to make a special version of it. So one of the things we have to do is my superclass has an init method that takes some arguments. So I need a way to pass name, price, and quantity to my superclass. So I'm going to define my own init method here that takes a name, a quantity, and a price. And I also want the tax rate for a taxable item. I want to know what the tax rate is here. Then to call my superclass, super, that doesn't look right. Should not have taken that type ahead. Super, name, quantity, and price. I think that's all we need. This is why you should look at the book occasionally. It's a good reference. So this will call my superclass, calling the init method. I think is it super.init? Might be super.init. I think that's it. My superclass, call the init method, given it name, quantity, and price. So that will run the item init to give a name, set price, and set quantity. Then I want to now go take self.taxRate and set it to the tax rate. Or again, maybe have a set method for that. Right? Maybe that makes sense to have a set method. So we'll define a get tax rate, returns the self.taxRate, self.taxRate, oh my goodness, tax rate. And then how about a set tax rate given self and a tax rate. Now this one's tricky here. When you ask someone what the tax rate is, and someone says 6%, if they were to type it in, they're probably not going to type in 0.06. That fair? They might type in 6. You don't want 600% tax, right? That's obviously bad. So what we want to do is we want to check to make sure and see what our values are. So we can say, hey, if tax rate is greater than 1, let's say tax rate, how about we divide it by 100? Because they probably gave me 6 instead of 6%, right? That's not okay? So we can do a quick little sanity check. If you told me 6 instead of 6%, I'll go divide by 100 and now I have 0.06. If you gave me 0.06, we're good, right? Nothing else has to change here. So then my self.taxRate can equal the tax rate. So do just a quick little sanity check. Again, you can do other defensive coding sort of things here. All good stuff. Set tax rate given the tax rate. Okay? Yeah.
Can you explain please the super.init?
So I have said that I am a type of item. I want to inherit from item. I want item to be my parent class. Item is my superclass. My item class has an init method that needs a name, quantity, and price. There's no way to make an item without giving it a name, quantity, and price. We don't have default arguments, but there's nothing here. So the only way you can create an item is by giving it those 3 values. So as a subclass, I need to give those values to my superclass so that it can create itself. Because I am one of those. I have all of the attributes and I have all those methods. And without those attributes, it's not going to work. Yep. So then what we need to do is we now need to make sure that by is different. So I have a method called by for my parent class, by. It does not include tax, right? So we need to include the tax rate. So I'm going to define the by method again here, given a quantity to buy. Now, again, I could do 2 things. I could copy paste and change a couple things and feel bad about myself, or we can do what my parent class does and then change it. So you even PyCharm is even nice in saying, hey, you're overriding your parent class behavior here. This little circle is telling me, oh, hey, it's going to override this, which is really nice. Did I do the wrong thing? I clicked something. No, it's fine. Okay. So like it's indicating, hey, it knows my parent class here. I've now changed the behavior of by. So what I want to do is I want to call my superclass, and I want to call by, given the quantity to buy. This will be my original, or before tax. How about that? Before tax is my super, is that parentheses? Yeah, okay, super parentheses dot by. I think I need parentheses here. So calling the by class, or calling my superclass, the by method. This will run the item by to give me the value. Then I can return my before tax times the tax rate. Times the self.tax rate plus the before tax. Right? So if the tax is 6%, calculate the 6%, add the original back, or like 1 plus the tax rate, right? 1 plus tax rate. Either way, right? Maybe 1 plus tax rate makes sense. Sure. So I can figure out how much it costs to buy that item. Okay? So all of that then, let's go back to, I don't know. How about the main PY? That's fine. And we'll put some more code in here. So I can make an item. So I want to say, how about from taxable item, import taxable item, and from item, import item. It will import both. So if I want to make an item to buy here, so we'll make apples equals an item. Its name is apples. Is it quantity or price? I forget which one's next. Item, price, and then quantity.
I think you put price first on the item and quantity first. Taxable.
Oh dear. Okay. Quantity, price, quantity. Good. Thank you. Yeah, that would be all sorts of bad. And that's what unit testing hopefully would catch for me if I flip those around, because that's no fun. So apples, and then the price, right? Price and then quantity. So apples are what? I don't know, $1 each. We usually sell them by the pound, but that's fine. And say we've got 42 apples. And then I can have cost is apples.buy, and I want to buy 10 of them. Right? Should be $10. We can print the cost. Again, unit tests would be better for this sort of thing, but we just want to try something real quick. We're running short on time. We'll come back to unit tests on Thursday. And then let's make now ramen is a taxable item. That's ramen noodles. They cost 19 cents each, and we're lucky, we just restocked, we got 100 of them. So my cost will be ramen.buy, and let's buy 20 of them, and let's print that cost. Now what we can do in debug mode, I'm going to put a breakpoint here, and we can watch these methods run, which is really fun. The debugger is your best friend here. So I'm going to right click and go debug instead of run, and it's going to pause when it gets here, so we can watch it jump into these methods and watch them run, which is really fun. Oh, I'm itchy now. Oh, that's right. So milliliters, sure, 10, whatever. We sprayed some bleach. Now we got to our pause. So we don't have apples yet. So we're going to step over, and now we have apples. If I did step into, it would have gone into that init method. So I'm going to do into here, step into my code for apples.buy. So you can see apples. You can see these are protected attributes. They're private, right? My apples, 1 and 42. So step into, and now the values change. The only thing I have here now is self which is the current instance, the one we called apples, and the quantity to buy argument here. So we said we wanted to buy 10. We have 42 of them. So I can see the code here. I can step. Now I have 32 apples left, and I'm going to return that cost. Then I see my cost is $10. Makes sense. So we'll print out 10, sure. Let's go to ramen. So I'm going to step into my code. Uh-oh. We got an error. I did a bad thing somewhere. Let's see. Is it not super init? Where's my console? Oh, we didn't give it a tax rate. That's okay. That's my bad. And what's the tax rate on ramen? So 0.06. There we go. So right here it said my init method was missing one required positional argument, was missing tax rate. So you read your errors from bottom up. Let's try that one more time. So I'm going to put the breakpoint here at ramen. Let's debug this one. And we can step in, 10 milliliters, sure, why not? Okay, now we step into our code here. Now we're at taxable item in the init method. We see price, we see name, we see quantity. Great. Now I want to step into again, and we're going to go into the item. This is the superclass init, where we gave it name, quantity, and price. Right, but self is still a taxable item. So as these go, we'll see the self, which is a taxable item, has protected attributes. Then I can call set tax rate, and now I have a self tax rate in my ramen. Oops, one more step here. Now I have ramen. There we go. So I see ramen is a taxable item. Name, price, quantity, and tax rate. When I buy ramen, if we step into here, my super.buy, I can step into that. It'll go into the superclass version of buy. So when you have a method that does this, what's called overriding, if it has the same name and arguments, or essentially list of arguments, because there's no like type checking here. Other languages work a little bit differently, but if it's by with the same number of arguments, it will call my version of it, not the parent class version, which is nice. So I can change the behavior so that you get the correct value out. And then we'll say, okay, great, I'm going to buy those. Now I have my before tax price was $3.80. I'm going to add the 6% tax. My cost here now was $4.02.8. Right? We've printed that out. So all of the things that item does, we're inheriting from by saying, hey, I just want to inherit. The init method gets to be a little bit tricky because we need all of those values in init to pass to our superclass, right? If your parent class needs arguments for init, you have to take them yourself, or if you know what they happen to be, we'll go for it. So a real common example, you deal with like a polygon that has some number of sides, and then you can make a rectangle. A rectangle is a polygon, and it knows it has 4 sides. You don't need to tell rectangle how many sides it has, where like polygon, you might need to know how many sides it has. So we can look at that on Thursday. We'll do some more unit tests, and we'll talk about the next project. That sound good? All right, awesome. That was fun. Kind of a blitz through. Again, this was covered in 1501, so bit of a refresher if you've had it before. If you've not seen any of this before, it's a lot. But all from Chapter 2. We can take a look at Chapter 2, kind of work on getting up to speed on that. We've got all of Thursday as well. We'll do some more practice, looking more at inheritance and using some cool things with inheritance. And there is really no limit. You can inherit and inherit and inherit and inherit and inherit as many times as you want. At a certain point, it's kind of crazy, but sure, right? At as many levels as you want, we can go for. All right, folks, let's end the stream. I'll put this out to YouTube, and we can go from there.